Hello friends, welcome to my channel. So in this video, let us discuss about the various phases of compiler. So what is a compiler? A compiler is a one which translates the high level language into a assembly level code. So assembly level code, it is nothing but a machine level code which the computer can understand. For this, the compiler, it will undergo through various phases. So let us discuss about each of its phases in detail. The first phase of the compiler is the lexical analysis. The entire process is taken care here. So let us consider this high level expression. So here the expression, it is given to the analysis phase, and the lexical analyzer, it takes the expression and it will produce the lexemes, and then the lexemes, they are converted as bytes and it will generate the token as a result. Again I am saying, so here this expression, it is given to the lexical analysis phase, and the lexical analyzer, it takes the lexemes as bytes and it will generate the token. What are lexemes? The lexemes, they are similar to words but with a small difference. The words individually have their own meaning, whereas a group of lexemes entirely convey their meaning. I have written this high level expression as in this format. Tokens are nothing but the meaning of the lexemes. So X, it is nothing but a identifier. The equal to, it is nothing but an operator. So the identifier, it is nothing but a combination of variable and a constants. So the job of the lexical analyzer is to find out the meaning of the lexemes. The lexical analysis recognizes the token using the reges. So what are reges? They are the regular expression which are used for the identifiers. So the identifiers, it may be a letter or a digit or a underscore. The identifier name will not start with a digit. Okay, then the lexical analysis phase, it will use the type 3 or regular grammar for the formal languages. In simple, we can say that in the lexical analysis phase, a stream of token is generated. Then the stream of token is passed to the syntax analysis phase, which is the second phase of the compiler. YAG, which stands for yet another compiler, uses this phase for generating the parse tree. The syntax analysis, it will generate a parse tree for the stream of tokens by using the CFG productions. What is a CFG? So CFG, it is nothing but context-free grammar. The syntax analysis phase uses type 2 or CFG grammars. So consider an expression x is equal to a plus b star c. For this, generate the CFG productions. They are nothing but set of variables. Capital letters are said to be non-terminals and the small letters, they are said to be terminals. So these rules, these production rules, they are used by the parser in order to produce the parse tree. So how the parse tree is generated or produced? So consider the first production. S is tends to id is equal to e and the semicolon. Here it is divided, as it is divided into 4. What does this expression means? This IE, it is nothing but an expression. This expression can be assigned to an identifier. ID, it is nothing but an identifier. And this expression, it needs to be terminated with the semicolon. This semicolon, it is also called a statement terminator. So then consider the second production rule. This expression, it can be an expression plus a term. Then this expression, it can also be a term. Then consider the third production rule. It means a term can be multiplied with a factor, or a term, it can be simply be a factor. Then consider the last production rule. The factor, it tends to the identifier. Thus the parse tree is generated. So here, if you want to find the yield of this parse tree, it should be traversed either from top to bottom or left to right. So let me show you. That's why ID, it is equal to ID plus ID star ID and the semicolon. So that is nothing but the yield of the parse tree. Since this yield of the parse tree, it is similar to the expression that we are having x, it is equal to a plus b star c. So it will not produce any errors. Otherwise, it will produce some syntax errors. The third phase, it is the semantic analyzer. So in this phase, the semantic analyzer will take the control. The parse tree produced by the syntax analyzer, it is given to the semantic analyzer. So here, it is responsible for type checking, array bound checking, and also it will check the correctness of the scope resolution. As a result, a semantically verified parse tree is produced in this phase. The semantic analyzer, it does the logical analysis of the parse tree, and it will examine whether the type of the identifier it is a variable or a constant. It also detects the multiple declaration of a variable, accessing an out of scope variable, mismatch between the actual and former parameter, misuse of the reserved words, and undeclared variables. This semantic analyzer, it looks for the meaningfulness of the parse tree and verifies. And then it goes to the intermediate code generation phase. So the intermediate code generator, it will generate a 3 address code. So the 3 address code, it is a popular intermediate code. The intermediate code generator, it acts as a middleman between the front end and the back end. So let's consider the same expression, x is equal to a plus b star c. Here the 3 address code for this expression, it is as follows. So first, t0 is equal to b star c, t1 is equal to a plus t0, and x is equal to t1. The t0, it is nothing but a temporary variable. So here this b star c, this part, it is named as t0, and the a, it is added to this part. So here it is nothing but the t0. So if we add this, so it is named as t1. So t1, it is equal to a plus t0. So we are naming the t0 as x, which is an intermediate code. And then the next phase is the code optimization phase. So here the code optimizer, it is used for the optimization process. The 3 address code which is generated in the intermediate code generation phase, it will be optimized here. So here this is the 3 address code which we have generated. So here how it will be optimized now. Here this is an redundant expression. So this is t1, it is nothing but this. So we can directly assign x to this expression instead of that t1. So it is reduced. So optimized, it is nothing but a reduced code. This code optimization, it may be either machine independent or dependent. Then the last phase of the compiler, it is the target code generation. So here the target code generator, it will produce the assembly code and it will be finally displayed. So here the phenomics are used. Phenomics, they are nothing but the instructions like move, mo, the then pointer. So these are nothing but the phenomics. So here in this phase, so the extended version of the AX register performs a vital role. So what is the extended version of AX register? It is nothing but EAX. So here it is the register which has the combination of both the high order bits and as well as the low order bits. So this high order bits, it is of 16 bits, and this low order bits, it is of 16 bits. So totally there are 32 bits in this EX register. So it is actually a accumulator register. Finally the assembly code is displayed. Let's summarize the phases. So what is the lexical analysis? So here the stream of tokens are generated, and it will go, the stream of tokens, it will pass to the syntax analysis phase. So this syntax analysis phase, it will generate a parse tree, and here after this the semantically verified parse tree will be generated in the semantic analysis phase, and then a 3 address code will be generated in this intermediate code generation phase. After that the produced 3 address code will be optimized in this code optimization phase, and finally the assembly language is assembly level code, it is produced in this target generation phase. And I hope this video helped you. So for more videos, subscribe to my channel, share with your friends. Thank you.